Well, hello everyone, and welcome to this Foundation for Water Research, or FWR event, The Impact of Agriculture on Water. This event has been organised by the FWR's Water Resources and Quality Technical Panel. And for those of you who aren't familiar with the FWR, FWR is a community of professionals from across the water sector and related scientific specialisms. The community comes together for deliberative discussion to support the development of interdisciplinary solutions to water challenges. And the FWR community provides guidance and strategic thought leadership for the Institution of Environmental Sciences water activities within which it sits, and collaborates with the wider IES family on issues related to land, air, and policy implementation. Once we kick off, for anyone interested, I'll put a link to our free newsletter in the chat so that you can kind of stay up to date with FWR work. But for now, I'm really pleased to hand over to Ian Davis, who sits on our Water Resources and Quality Technical Panel and will be chairing the event today. A massive thank you to you, Ian. I'll pass over to you.
Good afternoon, everybody. Thanks for coming along. This should be a really interesting discussion today. Water is fundamental for life. Too many people take it for granted. Humans have impacted on the hydrosphere pretty much as long as we've been gathering together in groups. And in many places today, agriculture is the biggest human impact on the water environment. Civilizations from China to Rome have modified the water environment for their own purposes, generally to support agriculture and for drinking. But because of their relatively small scale, the impact was limited. The 20th century saw a huge increase in human population, which has supercharged the impact of agriculture on the water environment. A lot of that impact has come from land conversion, from natural uses to agriculture. And in the last 50 years or so, the globalization of the food industry has again increased the impact of that through the water footprint of foods moved around the world, often from quite dry environments to environments which are much more suited to the water content of food production. Today we have an excellent panel. We have Professor Jerry Knox from Cranfield. We have Professor Mark Mulligan from King's College London. We have Danny Coffey from the Affinity Water, a water-only supply company in southeast England, and Finlo Costain, who I'll leave you to describe when the time comes your background, Finlo, given how broad it is. Our first presenter is Jerry Knox, Professor of Agriculture and Water Management within the Cranfield Science Institute at Cranfield University. He has 33 years of international experience in the science, engineering and management of water resources for agriculture, particularly assessing the relationships between water resources, drought, agricultural productivity and the environment, and the sustainability of agricultural production in the context of climate impacts and food security. His research interests are in biophysical and water resource modelling, irrigation agronomy, soil and irrigation management, abiotic impacts on crop productivity, mainly drought, and climate change impacts and adaptation responses in agriculture. Over to you, Jerry.
Thank you, Ian, and thank you, Effie and the IES for the invitation to talk today about, in this case, I'll be focusing very much on a UK-centric perspective, although half my work is international. But today, I really want to highlight some of the risks and opportunities facing UK irrigated agriculture, drawing on some research that myself and colleagues have been doing with the industry over the last few years. Now, I guess the starting point really is just recognizing some of the climate, the regulatory and the water related risks facing the sector. And we can think about acute shocks or chronic shocks, those that are short term and have a high impact like floods and droughts and need operational sort of rapid coping strategies, compared to those that are more longer term chronic, which need strategic planning and importantly working together in collaboration. And I'll just unravel a couple of these issues in this short presentation. But I think we can focus really mainly on two main areas. One is the climate shocks that we're facing, both an excess of water with floods, but also increasing frequency of droughts. And the other is having to cope with a raft of environmental regulation, and particularly changes in abstraction management and licensing, which are impacting on the sector. But if we just look at the last 5 years here, or five recent years, this is an agroclimate index across the country, across England, showing just how 2018 and 2022 were particularly arid years. 2021 was quite the reverse, a particularly wet year, and then a benign year in 2019 and a dry year or average year in 2020. So each year giving us a different climate signal and a response needed by agriculture, and also depending on where you are in the country, how those impacts then play out and what the adaptations might be. If we look at, again, the same data, but in this case for a given location, we can see a range of different years, from an average year to a very wet year to a dry year. And our 2025 agroclimate that we experienced last year well surpassed the conditions that we experienced in 1976, which many of us would consider was our biblical drought. So we're getting these extreme events that are coming through in fast succession, often one year after the other, making it particularly difficult for the agricultural sector, both rain-fed and irrigated, to respond to that climate signal. And of course, we only have to look at our water resources to see how that plays out in terms of water availability. And the recent droughts in 2018, 2022 and 25 really emphasising the problems that the sector faces in terms of security of supply. This has led to impacts on both rain-fed and irrigated systems, but also livestock in terms of security of feedstock for winter feeds, for refilling reservoirs ready for the following year. And again, this year we're in the middle of a winter drought, which is going to create problems for planting programs for 2026 in the spring. So we mustn't just think about summer droughts, but also the effects of winter droughts on our long-term planting and cropping programs. Of course, if we look further back beyond the last decade, we can see a number of years in the recent past that have created flood risk, but also drought risk. And so for those that are of the older generation remembering 76, we can actually go back to the 1930s, 1920s, and we can see that there are some drought events that were even more profound than 76. But for the younger generation, they're still having to cope with these recent interlapping drought and flood years, which is creating a major set of problems. So we've got a raft of climate problems, but we've also got environmental water issues as well. And these can be expressed through a lot of interest at the minute in the environmental destination targets, which is the government's approach to restoring ecological flows, to restoring aquatic dependent habitats, and in this case, reducing allocations to agriculture and other sectors, public water supply, navigation, power generation, and others, in order to restore the water balance, supply-demand balances at the catchment scale. Now, the red subcatchments highlight where the greatest reductions in licensed allocation are expected. They may not necessarily happen for a range of reasons, but this is what is being forecast. And on the left, we can see where irrigated agriculture is concentrated in the east, particularly east and southeast, the West Midlands, and the Nottinghamshire Sandlands, where if we look at the right-hand map, we can see that they overlap almost directly with many of the red catchments where there could be quite high levels of annual licence reduction. Now, one of the responses to these externalities is to think about how do farmers cope with low and high flows. The low flows are the challenge for the growing season, but the high flows offer an opportunity to scalp or harvest these high flows into storage and to then use that water in the summer season when the low flows are more likely to occur and cause problems. And we could arbitrarily just look at a Q98 flow. This is for a site in Shropshire, And we can see that actually during the summer, not just the winter, but in the summer periods, we do get quite a few occasions through the year when we do experience high flows. And therefore it raises the question of, well, what can we do about harvesting these high flows and putting them into storage and reducing our dependence on low flows, which are increasingly unreliable and are, of course, competing with environmental demands. Now, I won't go through this, but we spent a bit of time calibrating a model, a hydrological catchment model for a particular case study. And then we looked at the opportunity for scalping or harvesting these high flows. And the graph in the top corner shows the blue column showing the annual volume that could be harvested at the Q98 level, ranked by year and volume, and then the number of days over which that flow exceeds Q98. The bottom right-hand panel shows the split between summer and winter and annual volume between the amount of water that could be scalped and the actual licensed volume that is allocated for agriculture in this catchment. And what we can see is there's a real opportunity here for almost entirely removing our dependence on summer abstraction and moving more towards peak flow, winter or summer abstraction. The left-hand graph shows the challenge we face, which is the relationship between pumping rates that farmers typically pump at and the number of days that they need to pump in order to abstract the water they need. Most of the pumps that we have in agriculture are generally around this left-hand area. But in order to pump at those short, high duration, high intensity peak events, we need much larger pumps that can scalp the floods at high rates over a shorter number of days. But that creates problems in terms of getting energy to the pump stations in order to increase pump capacity and pump duty. So a more realistic option is probably to move towards having offline lagoons that can then spill the flood into these lagoons and then use existing smaller pump sets to gradually pump the water into existing storages. So there's a technical and engineering challenge here, but it is not insurmountable in terms of moving away from low flow dependency to high flow dependency. And then just finally, another part of the jigsaw is providing advice to farmers in order to understand when these high and low flows may be coming through the system. And we've developed a prototype high flow, low flow tool, which takes advantage of machine learning and a process called LSTM, long short-term memory, in order to simulate the flows at a certain point and then compare them against the observed flows. If we can integrate data on radar, rainfall radar, then we can forecast the likely flows in the next two to 3 days. And this can give farmers and others in the catchment a line of sight over whether the flows in the particular river or stream are actually declining or on the rise, or indeed static, and how these relate to any hands-off flow triggers that may be present in the catchment. So we're starting to use technology and advanced wireless sensors, linking through telemetry, working with the Environment Agency and farmers to try and move towards more intelligent, smart agricultural water management. And the reason we're doing that is if we work in isolation, this graph shows the annual irrigation deficit that individual farmers working at the business level, so the red line, they could experience deficits of around 1 to 1.5 million cubic meters in a dry year. But if they work at the tributary or the subcatchment or even catchment scale, we can bring right down this irrigation deficit threat through water sharing and through smart agricultural water management, so that farmers can work together, they can share their water resources, they can move water between businesses, but it does need regulatory change and greater flexibility from the agency in order to facilitate it. So in summary, there's a big opportunity here to scalp high flows and to reduce our dependency on low flows, but we do need some regulatory flexibility. and we do need to sort of take advantage of the sensors and the tech that are now at our sort of at our hands. All of this information is presented in this booklet, where the link is given on this final slide. So I will finish there and hand back to Ian. Thank you.
Thank you, Jerry. Very interesting presentation, which we'll get into once we've all heard from all of the panel. The next speaker is Danny Coffey from Affinity Water. Danny is the catchment manager at Affinity Water, and he manages a team of advisors who work collaboratively with farmers and landowners across priority catchments to support regenerative farming practices and nature-based solutions. He has 10 years experience in catchment management and a strong interest in using field trials and robust data to shape catchment schemes which can drive beneficial change for the environment, water, soil health, and crop productivity. Over to you, Danny.
Thank you, Ian. So hello everyone, I'm Danny Coffey, Catchment Manager at Affinity Water, and I've been working in catchment management now for 10 years. And the team really seeks to understand sort of water quality challenges and other risks out in a catchment and use solutions in a more sustainable way, rather than purely relying on water treatment. So I'm going to talk to you today about Affinity Water's catchment programme and funding schemes that we have to help farmers. But first up, Affinity Water, we're the UK's largest clean water only supply company, with approximately 3.9 million customers in the southeast of England, and we supply them with an average of 969 million litres of water per day. Now, approximately 65% of our supply comes from groundwater, mainly the Chalk Aquifer, and the remaining 35% comes from the River Thames and imports into our network. There's a number of challenges across our supply area. We've got a growing population with high water usage, and in combination with climate change impacting weather patterns and aquifer recharge patterns, this area is classed as water stress by the Environment Agency. And our supply area is also home to around 10% of the global supply of rare chalk stream habitats, which are fed by the Chalk Aquifer as well. So we're focused on providing long-term sustainable, high-quality drinking water whilst protecting the environment. So we've reduced groundwater abstraction already by nearly 100 million litres of water per day, and we have a further 35 million litres of water per day reduction plans for 2030. Therefore, it's vital we protect the groundwater sources that we do still have available to us. And that leads on to the challenge of water quality and pollution. There's a number of water quality challenges which impact our sources, especially during heavy rainfall events, which can also impact chalk stream ecology. And agriculture can be one of those challenges which I'll focus on today. So the main risks for us from agriculture are nitrate and pesticides. On the left, you have a graph showing a source in North Hertfordshire in the Chalk, impacted by steadily rising nitrate concentrations since 2002 and earlier, really. Sources can reach over the drinking water standard of 50 milligrams per litre in raw water under high groundwater levels. And then we have to import water at a higher cost when this happens due to limited blending in the area. And because nitrate takes decades to move through the soil profile and chalk matrix, we want to reduce this trend and any further excess nitrate being lost from agricultural fertiliser use using catchment interventions. There's also losses from pesticides, which pose a risk to our surface water sources and some groundwater abstractions as well. One of the main ones is propyzamide, a herbicide used in oilseed rape and winter beans to tackle grass weeds. We also struggle with flufenicet as well, which is used in cereals. And we have a strict 0.1 micrograms per litre drinking water standard for all pesticides. And as you can see, we see seasonal spikes over this in the raw water in River Thames. And this poses a risk operation need to treat it down and puts pressure on processes like granular activated carbon. So one key regulatory mechanism for investment in the environment is the Water Industry National Environment Programme, or WINEP, regulated by the Environment Agency, and it's to ensure that Water Framework Directive obligations are met, which means that the quality of all water bodies needs to be protected from deterioration, and quantity and ecological status also needs protected, ensuring resilient supplies for both people and the environment. And in the water industry, we work in 5-year regulatory cycles known as asset management periods. We're in AMP8 2025 to 2030 at the moment. And Affinity Water's WINET programme focuses on reducing abstractions from the chalk aquifer, river restoration, and using catchment and nature-based solutions, which is what my team's focused on. So the map here shows our priority areas. The blue areas are where we have drinking water. We're implementing measures for drinking water protection to address pesticide and nitrate risk. And the green areas are where we're restoring chalk streams, and the catchment management team is working to implement catchment and nature-based solutions to further protect chalk stream water quality, but also create more resilient chalk catchments and see if we can increase recharge and realise wider natural capital benefits. And our regulators have stipulated that catchment nature-based solutions we invest in need to be long-term and lead to lasting change across catchments. So we've designed our unpaid funding schemes for farmers with 3 elements in mind, which we believe can lead to this longer-term wider change. So we've got our functioning soil schemes, which cover the blue areas on the map that I just showed you to protect water quality. And through the years, we've realised that soil health is really key here, acting as a natural filter to treat and store water, and living soils can cycle nutrients more effectively. And the aim here is to provide per hectare contributions to farmers to move towards regenerative agriculture and beneficial land management practices such as cover and companion crops to help build soil health in the long term. We're very much linking this to knowledge exchange around soils now to try and drive behavioural change around soil management and support farmers to try new approaches through innovation grant funding and support to access new markets. The second pillar of funding that we're offering to farmers now is about supporting collaborative action and drive real change across landscapes through farmer cluster support. This can promote knowledge exchange and on-the-ground projects. And the third pillar of support, which we've only launched in 2025, this is funding for landowners to take unproductive parts of the land and implement nature-based solutions which can protect water quality and also lead to multiple other natural capital benefits such as natural flood management, aquifer recharge, biodiversity, carbon sequestration and more. So we need to show our regulator, the Environment Agency, that regenerative farming practices like cover and companion crops benefit water, and we need to evidence this. So in the top left there, you've got a cover crop. Cover crops are drilled over winter to prevent ground from being left bare before a spring crop, and companion crops provide additional cover within a cash crop, and both break down and provide organic matter to the soils. So we use field trials to build evidence for our regulators and also to show farmers the benefits as well. For example, we've been working with ADAS for the last 4 years on the nitrogen release from cover crops trials work, and we've consistently found that cover crops lock in around 30 to 40 kilograms of nitrogen more per hectare than stubble plots, and also there's significantly less leaching from cover crop plots, as well as some yield benefits that we've found as well. We've funded over 13,000 hectares of both cover and companion crops since 2020, and we have a further 3,000 hectares supported in year 1 of AMP8. We've also teamed up with Pharmacy and Hutchinson's Agri Consultants to provide a series of soils connected courses for 36 farmers in 2025 and 2026, managing over 4,000 hectares across our priority catchments. So this is about bringing in that knowledge exchange. It consists of 5 sessions held over 5 months, where farmers learn about the physical, chemical and biological health of their soils and how these properties can impact nutrient uptake and productivity. And at the end, farmers make commitments to changes to benefit their soils. And there's a potential route here for us to channel innovation funding in the future and tailor schemes to farm businesses' needs in areas which could impact our sources. We currently offer innovation funding for soils for farmers, and here's an image here of a subsoiler that was modified by a farmer to make it low disturbance. And this is a way for farmers to try things new to benefit their soils. And we're also for farmers that are trying to access new markets, and some of you may have heard of Wild Farm, for instance. They offer farmers a premium for growing wheat to their regenerative standards, including the use of by-crops such as beans to fix nitrogen from the atmosphere, and the need to optimize and reduce nitrogen inputs, reducing the chances of losses. So we pay a water premium on top of this to try and increase the uptake and help drive market change. And we've seen catchment measures in relation to the herbicide propionamide work as well on the ground. Propionamide used in oilseed rape between November and January time when we get heavy rainfall normally. And this is a high risk catchment in Hertfordshire characterised by karstic features known as swallow holes, and we have groundwater sources there where we see rapid deterioration when pesticides from the surface water enter the groundwater very quickly. And over this 2-year period, we ran a reverse auction and funded farmers to grow alternative break crops to oilseed rape, preferably a spring crop with a preceding cover crop which do not use propyzamide. And where we did have oilseed rape still, we funded them to grow companion crops. And our trials data in the top right there shows that bursting clover grown within an oilseed rape can greatly reduce the concentration of propyzamide at 40 centimetres and potentially being lost from fields. And as you can see on the left there, the catchment concentrations were greatly reduced the years where we ran this auction, and we had no significant detections in the raw water or our groundwater source, benefiting our treatment processes as well. And in AMP8, we've started to fund innovative nature-based solutions now as well, which are more more permanent long-term solutions to protect groundwater and surface water, as well as chalk stream health and create more resilient chalk catchments. And this can also lead to other natural capital benefits around aquifer recharge and biodiversity, which we're exploring at the moment. So in June 2025, we launched the Water in the Landscape grant scheme across our priority catchments to landowners who could apply for up to £15,000 contribution to projects. It was a competitive process, and we accepted 13 projects in total for year 1, including some agroforestry projects to improve soils, some chalk grassland restoration, creation of a wet woodland, and reed bed projects to treat water and more. And there is some existing research out there, but the aim here really was to quantify and gather evidence across our priority catchments and report to our regulators. So we've already started to install Sentex soil moisture and also some nitrate sensing probes at the agroforestry sites. We're also planning some soil acoustics, to use the soil acoustics to track soil biology enhancements and see how that links to the water holding capabilities, as well as targeting water quality probes for turbidity upstream and downstream of certain features. And the key here is to really build strong nature-based solutions, case studies in AMP8, whereby we can understand the benefits, the spatial spread that would be needed to bring about real change and help shape our investment for AMP9 as well. And lastly, the newest form of support that we have on offer to farmers is where we have groups of farmers that wish to create cluster groups across our priority areas to work towards common goals, which align with our ambitions. We've committed funding towards 9 groups in year 1 of AMP8, all with slightly different aims. Some farmers are focusing on knowledge exchange around soil health and more profitable farming. Others have specific projects around improving farmland birds and biodiversity and river corridors. So more project-based work around specific nature-based solutions. But if they include water and can benefit water, then they can apply to our fund. So it's still early days of this fund yet, but it's key for us here is farmers can help us monitor these benefits, increase uptake easier than we can do on our own, and also help shape our funding schemes going forward. So in summary, the approach we've taken to catchment and nature-based solutions for the benefit of water is really made up of trying to help farmers see the benefit in managing their soils, and knowledge exchange has been a key element here, because knowledge can really lead to permanent change to soils, but farmers have to see that business need to do so, and each need is going to be different for each farmer. So through these soil connected courses, we can potentially tailor funding to individual farm businesses here. So we have some evidence for the benefits of soil health focused regen farming practices, but we're continuing to run field trials, and we can potentially do this through these knowledge exchange groups as well. And we do need more evidence around nature-based solutions, hence why we're rolling out extensive monitoring of those pilot projects in AMP8. And as we progress forward, we can potentially feed this data into modelling to look at the best way to target and use budgets in the future to benefit both surface water and groundwater. And finally, the financing of nature-based solutions and blended finance is going to be important, because we can't fund it all. We're already a buyer of ecosystem services through the Landscape Enterprise Network for the East of England, which is showing potential as a way of bringing together private finance within the agricultural supply chain. We're also topping up sustainable farming incentive payments for farmers. So there's opportunities out there, but hopefully more to come for farmers and landowners to carry on progressing and farming in a way which is beneficial for crops, water and the environment at the same time. So thank you very much for listening.
Thanks, Danny. Some really interesting stuff in there, which I'm sure we'll get into. And I see there's a couple of questions for you already in the Q&A. Up to you whether you want to answer them now or whether we pick them up later, but we may do both. It leads nicely on to Professor Mark Mulligan, given the talk about the importance of monitoring. Mark is Professor of Physical and Environmental Geography at King's College London and also Honorary Fellow of UN Environment World Conservation Monitoring Centre. He works with a large team of PhD students on a variety of topics in the areas of environmental spatial policy support, ecosystem service modelling, and understanding human impacts on the environment and their consequences for society. This research is at scales from local to global, and with a particular emphasis on tropical forests, mountains, and drylands. He's a developer of a range of open data sets at geodata.policysupport.org and free web-based policy support systems at www.policysupport.org. These include hydroclimatic and land cover data sets and the Water World hydrological and costing nature ecosystem services modelling tools. His research involves fieldwork around the world, and he is also a developer of a range of open source instruments for environmental monitoring through the Free Station and Free Sensor concepts. Over to you, Mark.
Thank you very much. So I'm going to take us a little bit more global in our conversation, but also reference the UK at the same time. We know that producing food is the most important human activity, but we also know it has significant impacts on water, which we need to carefully manage. And those impacts can be categorized into impacts on water quantity, impacts on water quality, and impacts on the regulation of water. That is to say, the timing of the availability of water through the year, flood and drought, as we've already heard about. And there are a few global numbers on these things, but they really do trace back to a small number of relatively undocumented sources, or indeed from expert judgment rather from any detailed monitoring or modeling. And so they remain highly uncertain, but let's give them anyway. Water withdrawals for agriculture, we often say 70% of our human water withdrawals are for agriculture, but the figure's likely to be somewhere between 45 and 90. How much of that is used consumptively? In other words, is evaporated into the atmosphere and is no longer available downstream? 85 to 90% is the figure that's usually given, with around 60% of that rain-fed and around 40% of that irrigated. So, you know, these figures do show that agriculture is a huge impact on global water. With most other human uses of water, non-consumptive, right? If we use water for domestic use and industrial use and so on, we change its quality, but it still goes into the river downstream and is available for use once it's cleaned up or diluted. In terms of global impacts of agriculture on water quality, we don't have any numbers on that. We know that water quality is degraded in various ways by agricultural contamination and so on, but we don't really have a clear global number. And in terms of regulation, we know that agriculture has an impact on the availability of what we call natural flood storage, areas in the landscape that can hold water, so it's not in the rivers. But again, until now, we didn't really have any numbers on that. There's also a lot of misuse of the concept of virtual or embedded water or water footprints out there in the literature. We talk of the water footprint as the sort of total fresh water that's used to produce a consumed good. So that's the evapotranspiration to produce a kilo of coffee, let's say, or a cup of coffee, and the water that's required to dilute the pollution that results from the agriculture that generated that cup of coffee. So that's the water footprint. And, you know, the concept was developed by a colleague of mine, former colleague of mine, Tony Allen, and he developed it for the drylands. And it works there because in drylands, you're replacing natural vegetation with irrigated agriculture, and you will always use more water in doing that than the natural vegetation would have used before you converted it. However, most of the world is not a dry land, and in more humid areas, once you remove the natural vegetation, you can actually decrease, in most cases, even under irrigation, the use of water compared with the use by natural vegetation. And so for most of the world, the so-called footprint of agriculture is negative, at least in terms of water quantity. In terms of water quality, yes, of course, agriculture still has a footprint wherever you are, humid or dry, on the quality of water. So it's important to sort of bear that in mind. And if we run the modeling on that, we see that the areas in red and in green here, they're the areas of the world where you always tend to have a water footprint in the sense of the word that's non-negative, right? Those are the drylands where that applies. So let's have a look to see if we can consider, coming up with some more rigorous numbers for some of these things. And so here we've done an analysis with very detailed global remote sensing data to try and account for some of these things. If we look at total actual evapotranspiration, that's consumptive water use, then this is the global map that we get. We can see where it's higher is red and lower is blue. And the numbers work out as around 10 times the global reservoir storage is evaporated every year. Of that, evaporation over pastures, so these are areas of grassland, but also other areas of sparse pasture, which can include areas with some trees and so on, that's a relatively small fraction, 2%, because not all of the vegetation in those pastures is a pasture, and also they tend to occur in drier areas. Whereas croplands are around 9% of global consumptive water use. The big bit of global consumptive water use is nature, forests, natural areas, and including the natural areas around agriculture. They actually consume the most water. It's important that they do, because that evapotranspiration drives productivity, it drives the ecosystem, it drives the production of rainfall eventually, in a cycle, of course, but they are the most significant. We also know that agriculture affects natural flood storage and that it affects water quality. We don't know for sure how much it affects natural flood storage, but we can say that of the natural flood storage that's in the world, the wetlands, the water bodies, the floodplains, the forests and the soils, around 18% of the volume of that storage is under agriculture. So agriculture will affect it in some way. And in terms of our total global impact on water quality, if that were 100% across all of our impacts, then a relatively small impact comes from agriculture, surprisingly small, really, because the dominant impact there is domestic water and is also contamination from roads and urban areas. Even though agriculture is a much bigger footprint, its impact per unit area is much smaller than those other uses, and agriculture as a result has a lower overall impact. If we look at the UK, then this is where the evapotranspiration is. It's 23 times our national reservoir storage capacity every year. Much more goes through agriculture. Pastures 21% in the wetter areas, croplands 12% in the drier areas of the country. Nature is still around 67% of consumptive water use. An enormous amount of our natural flood storage is under agricultural land use in the UK, around 69%. And the agricultural impact on our human water quality footprint is a bigger impact than the global average, again, in the UK. However, we don't know the detail, and we don't know the detail because monitoring is often sparse, intermittent, or even if the data is collected, it's unavailable. If we really want to understand the impacts of agriculture on water, we need long-term continuous weather station networks. We need more information on dams, reservoirs, irrigation withdrawals. We need better global crop mapping. We need more accurate groundwater storage and depletion data, we need comprehensive land management data and comprehensive soil data, as well as information on water rights and pricing and subsidy regimes around the world and what that does to farmer behavior. We have relatively little on all of those things, even in countries like the UK. Here's an example. Our global dam watch database that's been developed over many years now has around 35,000 dammed reservoirs in it. But on the basis of those data, we estimate there's probably around more than 4 million reservoirs worldwide, but we don't know where they are. There's no global database on that. There are no global databases of water transfers. There are no global databases of irrigation channels, none of that. Even so, our estimated reservoir water storage, if we were to extrapolate to those 4.4 million, would be around half of the total water storage in the atmosphere at a given time. So it's an enormous part of the global hydrological budget. Weather stations, well, unfortunately, we do have a dense network in some countries, in the United States, in parts of Europe, Australia, etc. But as you see from the colors, outside of those areas, around 30% of the data is missing, and the number of weather stations is declining over time. In Africa, we only have 200 high-quality weather stations in the whole continent. Yes, but there's remote sensing, isn't there? And there's AI. Well, yes, there is, but you still need on-the-ground data because there are certain things you just can't measure with satellite programs, and also satellite programs are expensive compared with ground data sometimes. So in conclusion, we know agriculture has a large impact on water. We know the impact is greater on water quality and natural flood storage than it is on quantity, because nature is the big impact on quantity. It's important that it is, though. We lack an understanding of detail because monitoring data has always been poor and is declining. Remote sensing is not a substitute for most of it, especially at the local scale. But there are some promising developments in both requirements and funding for monitoring that are associated with investments like we just heard from Danny, where you get the investment, but you have to monitor the outcome in low-cost sensing and in farmer and community-led monitoring initiatives. Thank you.
Thank you, Mark. There's an awful lot in there to unpack, so we shall come on to that, I'm sure. Our final speaker today is Finlo Costain. Finlo is the editor-in-chief of 8.9.com and has worked in farming, land and food business policy for over 20 years. As chief executive of Farmwell 2016 to 2022, he gave evidence to UK parliamentary committees and advised ministers and the Committee on Climate Change on the role of agricultural climate gases. Finlo founded the Food and Global Security Network in 2020 and published Soil Health, a security threat profile, prior to COP26. Finlo has presented at the European Parliament and advised ministers and senior leadership teams in many European countries. His TEDx talk, "We Can't Solve the Climate Crisis Without Cows," has proved highly popular with regenerative farmers and innovators. Over to you, Finlo.
Thanks very much, Ian. Thanks for the invitation as well. I'm not a scientist. I'm not sure how many scientists are watching, and I'm looking at the data that's sort of been presented and thinking I'm lightweight by comparison. So we'll see how we get on, and I'm going to sort of whiz through this. And if you want more detail on anything, then I'll endeavour to provide it during a sort of Q&A as we go. Let me see. This is going to move. Yeah, there we go. So the thing that concerns me in terms of farming and water, it's all about trying to get water to move through the land rather than over the land. And at the moment, we have a situation where the vast majority of water that's falling out of the sky in the UK is going over the land rather than into it. A very small amount going in. And Mark talked about 69% of natural flood storage being under agriculture, but much of this is poorly functioning agricultural land. The water isn't getting in there, so we could make a vast difference very quickly. Of course, when that land is poorly managed. There isn't the infiltration. The water sits on it as flood, causing problems for the farmers, building up the conditions for disease, stopping things from growing, or else it runs off. And when it runs off, obviously it creates flood problems further downstream. That flooding from each of those different fields then compounds and can cause incredible flooding. Around the village where I live in Dorset, we really genuinely don't need to have any flood problem at all. And yet for many weeks or months of the average winter, I'm driving through inches of water for hundreds of yards to get out of the village, because the land around here effectively is operating like a concrete car park because of the way that it's been managed. Obviously, as that water runs off the land, any nutrients that are in it, along with a lot of topsoil aggregate, is being taken off as well and flushed ultimately into drains and out into the sea. Where you have grazing land, heavy animals, hooves, you get water on the soil where those animals are congregating around feed that's been brought in, or other areas, shelter. You'll get poaching, and again those tiny little ponds, those sort of areas of land that are sort of created by the hooves, the depth there, you'll get disease, worm burdens, that sort of thing increasing there. And of course all of that increases the costs to the farmer in terms of dealing with the symptoms that are associated with that. Whereas well-managed land will allow that water to be absorbed and held in a vast reservoir, basically within the soil, held during the winter, then released during the summer, so that the water isn't causing a problem. It is helping and boosting soil fertility year round, and meaning that at times of drought that water becomes available. Obviously it reduces flooding, retains the nutrients, and reduces disease, as I mentioned. Now there is a global context that's been sort of referred to already here. Ecological security I always think of as being sort of above food security. Food security critically important, but we can't have it unless we have ecological security. We're already at 1.5 degrees C. It's not been officially designated, but we all know it. We all know also that we're likely to be at around 2C, possibly more by 2040, 2050. I've been to various presentations by people like Tim Benton from Chatham House, within the work that I do on the Food and Global Security Network. And Chatham House has been trying to model business as usual, how society moves forward in a business as usual scenario, and they simply are unable to model past 2050. Society collapses before that. And that's a big statement to make, but this is Chatham House making it rather than me, and they struggle to get past 2040. Part of that is to do with global warming. Part of that is to do with water cycling, biodiversity rapidly declining, and of course global instability increasing by the day sometimes, let alone the week. Venezuela, the takeover by Trump there, a sort of collapse of the rules-based order, attractions over Greenland if America goes in there. What happens in terms of global security? How will Russia, China respond? It's not within the realms of possibility to suggest that there's going to be global war at some point in the next 20 years. And if that happens, then that's going to interrupt an awful lot of the supply chains that we rely on in terms of fertilizers or machinery, AI, technology, all kinds of different things that currently come from around the world. And so that resilience becomes ever more important within the UK itself. So how do we deliver resilience? It's about a swift pivot away from fossil fuels. And in doing that, you're going to reduce your input costs as a farmer significantly. If you're reducing the amount of imported feed, the fertilizers, the petrochemicals that you're using, you reduce those costs. Yield may drop a little bit in the short term, although it may build, and it may actually increase over the longer term if you recruit nature's functioning, nature's architecture, use natural infrastructure rather than just built and technological infrastructure. And if farmers focus on profit rather than yield, then by the time they've stripped away those external costs, they find that they are earning more money. Now, part of this is about recognizing that nature isn't something that happens at field edges, in those bits of woodland, the pond, the stream that's going past, but actually soil itself, the center of a field, is just as important as anything else, and that soil is the key habitat and the foundation of all biodiversity. Biodiversity begins in the soil, cascades upwards, outwards, downwards, everywhere from there. But it means that the diet that we have in the UK needs to become much more land appropriate. Farmers don't just grow what they've always grown or grow what they fancy. They grow what that land can support, and that our diets reflect that nationally. And the Nature Friendly Farming Network, who I work with quite a lot, they did this assessment in Wales specifically. They found that once those costs are stripped away, that can boost farm profitability by over 40%. I should mention that one of the things that I do, you can see just on the screen next to me, is the Farmgate podcast. This has been going for more than 5 years now. We're the world's highest ranking food security podcast, almost the highest ranking in terms of regenerative agriculture. We produce stuff every week, sometimes more than once a week. One or two of our monthly shows. One is with Joe Stanley, where he and I are having discussions about news and items that are relevant within that sort of previous month. He's from the Allerton Project, the GWCT Allerton Project, where they do lots of work, innovative farming there. And another is called Martin's Farm, where it's talking to Martin Lyons, who runs the Nature Friendly Farming Network. That was a quick plug. If we're looking at soil health and diversity, I'll just show you the difference in terms of if you have a mixed sward, herbal lays, decent rooting, rather than the sort of monocultures that we tend to see on farms today in Britain. This is perhaps rape or something that's growing up, I'm not quite sure. But if you think of perennial ryegrass is the standard thing that you see on a dairy platform. Inches, the roots are only a couple of inches deep, 2 or 3 inches deep. That means that the water can only infiltrate that far. Where you have deeper roots, you have water infiltration going down as far as the roots, sometimes down as far as the bedrock. And where you've got those deep roots, they're supporting the mycorrhizal fungi, those sort of clusters and communities of arthropods in there and bacteria, which are also important. As they die, the roots die, they're creating more pathways and aerating the soil, drawing down carbon, building necromass, building nutrients as we go forward. And as we know, soil is life. It is essential for life on Earth. Now, regenerative farming is one way of delivering this, but you can think of agroecology, nature-friendly farming, organic farming, a whole range of different things. Regen is kind of in the zeitgeist at the moment. This is about prioritizing and re-establishing natural systems, rebuilding soil fertility and that biomass that I've been talking about. It's about cycling sunlight and water and nutrients. And if you think of the sun as being the energy that is hitting the ground, then the water is the battery that holds that energy with the nutrients in the ground, both absolutely essential. And what regenerative agriculture is really about is reversing the trend of the last 80 years towards simplicity, towards being able to grow one thing in a field. If you identify a single pest, being able to target it and get rid of it, to recreating diversity, recreating abundance, because with abundance, nature begins to manage itself efficiently and to work for you as a farmer. I'm not going to go into this because of time. It's essentially just going over things that I've already said. But if we think about this in terms of dairy farming, I'm just going to go through dairy and arable. How do we deliver that soil health, that water functioning in the land? You eliminate pesticides and fertilizers, at least as far as you can. And for many farmers, it'll be completely. You're adding trees and hedges, using mixed deep rooting swards, and you're rotating stock. If you've just got stocking systems, they're not making that land function. Whereas if you're moving them through paddock grazing of one kind or another, then you're going to get a huge boost in the amount of biomass, the sward, the grass that's being created there. And as that sward is boosted, so is that functioning in the soil and the drawing down of water, the cycling of water in there. Now, with some farms, they will see that there's quite a significant yield drop. But those farmers are successful because they're not just selling into the liquid milk market, but their milk is higher in terms of its nutritional content, but also they may be selling directly to the public, or they're producing cheese, added value products and that sort of thing. A couple of podcasts ago, I spoke to a guy called Stuart Rogers from Longmoor Farm in Dorset. He's still producing high yields. He's still using a reasonable amount of imported cake and food that's given to the cattle when they're actually milking. But out on the grazing platform, the life and abundance of wildlife out there is phenomenal. From herbal lays, the agroforestry that he's got there, no fertilizers, no pesticides. And so essentially from grass and from that abundance and diversity, he's still providing as much milk into the liquid milk market as is going anywhere else, coming from anywhere else. Slurry management, really key. We have this crazy situation in the UK at the moment where we have a closed season over the winter. What that means is that farmers try and get rid of all of their slurry in the weeks leading up to the start of that closed season, often regardless of the weather conditions, putting it out on their fields. Then they can't put it out on their fields. It builds up and builds up and builds up, and sometimes leaks out into the yards, into the environment. And then as soon as the season opens again, they're throwing that slurry out onto the field again, often regardless of the weather conditions. There's an innovation, the Tui Tui weather app in South Wales, which is rather interesting. So farmers there have been licensed with the app to spread slurry year round. What they're doing is using the app. The app gives them a traffic light, whether it's red and you shouldn't be spreading your slurry, amber or green, assessed on weather information that's coming in to the app managers and so on. And that's working incredibly successfully, enabling that slurry year round and meaning that there isn't this kind of huge nutrient outpouring at particular times of the year. Riparian abundance, what I mean by that is anywhere around watercourses, making sure there are lots of trees, lots of nature, grasses, flowers, all that sort of stuff, so that if there is nutrient leaching, then that's going to sort of provide a buffer. And just, I think there was a question that was coming in about sort of how these things get paid for. And First Milk, for example, who we work with quite a lot, they call themselves the regenerative dairy. They are paying farmers 1.6 pence per litre on top of the standard milk price for delivering regen, and that's funding that's coming in from Nestle. And then you have organisations like Waitrose, companies like Waitrose, that are working very directly with their farmers to try and establish better conditions to share knowledge. In terms of arable farming, it's about soil testing, collecting of data, and therefore being able to reduce and eliminate nitrogen. Cover crops, so with cash crops, you're growing a crop that you then harvest and it makes you money, some cereal. And then in between you have a cover crop. So never leaving the land bare, never leaving it naked, making sure that cover crop is there. Intercropping, so here in this picture we have wheat along with beans, I think, and so they can be harvested together and then treated separately, sort of separated and so on quite easily. If there is ploughing taking place, that should be as shallow as possible. And then if you've got those cover crops, you can just push them down and drill directly, plant directly into the sward there. More difficult to deliver the regeneration in perennial arable systems, but there are ways of doing it. And again, affinity water, we were talking there, Danny talked about the relationship that he's got with Wild Farm. So Wild Farm employ farmers to farm and grow wheat in a particular way, in the wild farmed way, which is then produced into bread, which is sold in places like Waitrose and so on as sliced bread. Affinity is paying farmers because they're farming in the wild farmed way, which means that there are very few nutrients going onto the land, which means that there's less nutrient leaching going out. So their affinity is paying for that land management. You also have nutrient trading schemes like the Poole Harbour scheme, where if you have farmers who are still very reliant on fertilizer, they will have to buy credits now from farmers who have managed to sort of reduce or eliminate fertilizers, artificial fertilizers from their systems, so that the amount of nutrients on the land going into the watercourses there then are staying at a particular level, a predictable level, and that level will be reduced year on year until balance is restored. The final thing really that I want to touch on here is natural flood management. If you haven't come across the term, then we're talking about leaky dams, which are the things that you can see in the pictures there. If you've got a tree that falls into a watercourse, leave it there because it will hold water back. Sometimes you need some staking in there, like the top picture, to make sure that those trees are staying there. Earth bunds, where if you think of Stonehenge, you've got the henge around the outside, the stones in the middle. These little henges, little earth bunds that are sort of created so that you capture the water. Maybe it's only an inch or a couple of inches deep, but if you've got enough of these bunds, it will make a big difference within the catchment, along with the deep rooting swards, trees, hedges, etc. And if I just mention the flood alleviation project in Stroud, if you've not come across it, it's remarkable, really fantastic. You've got an officer there within Stroud District Council who's quite unusual because he has a fantastically can-do attitude. And so following sort of 10, 15 years ago when there was a big flood event in Stroud, he's been working since 2014 on natural flood management. As you can see, 1,000 interventions throughout the wider catchment there. If a farmer has come to him and said, I'd like to do this, he hasn't done a great big survey across the whole area. He's just said yes and paid the farmer a day rate to get on with it. So 25, and so the costs have been incredibly low for actually getting these flood managements in place. 25% of the catchment now draining through these features. There are several rivers and streams flowing through Stroud. Slad Brook was the particular challenge back before 2014. Now a 1 metre reduction in peak river levels as a result of the natural flood management, just showing the power of holding water in the land there. Where does the money come from? It comes from farmer change. Farmers will be farming more cheaply. They'll have fewer direct costs. That, they're obviously a key stakeholder. At the same time, the government, the public, through policy, through subsidies, has been telling farmers how to farm, sort of prioritising food over nature and natural systems for 80 years. We're now changing that. But it's really important that the public and the government doesn't abrogate its duty to pay for that transition, to help farmers to change their knowledge, to make sure that they're implementing these new systems on their farms. Direct relationships with progressive customers, I've mentioned First Milk and Wild Farmed, utilities funding like that's coming from Affinity, blended finance, landscape scale recovery programs. Again, the Even Load Landscape Recovery Project is really worth just having a glance at. They're getting money as well as from water companies, from rail companies, because of course rail companies can't run their trains when the lines are flooded. So there's a real vested interest from the market, from private interest, from government, from the public and the farmer in delivering these things across hundreds of farms at scale, but finding bespoke solutions often that are paid for separately across that catchment. I believe that's it. I've talked a lot. Thank you.
It's hard not to at times, isn't it, Finlo? Thank you for that. You've although you apologised for not having a scientific presentation, I think you've drawn some of the issues together very nicely from the previous presentations. Interesting, just an interesting observation I was thinking about during the various presentations. Isn't it ironic that that we're increasingly offshoring the UK's food production into ever drier environments? I was listening to a BBC Food Programme podcast the other day where they were talking about, in the middle of winter, 30% of our vegetable production is coming from 2 farms in Senegal, in Western Africa, entirely irrigation driven. That's the sort of thing that we're talking about. And the whole thing about slurry with dairy production and pigs as well. And the perverse incentives that the food industry has presented with the increasing indooring of livestock when they really need to be part of functional natural environments. Question for Jerry and Danny in particular. Prioritisation of water rights. There's a consultation, I believe, coming out or out now from the UK government around prioritisation of water rights. Have you any particular views around that issue, given how significant it's going to be with the water availability impacts of agriculture across the eastern counties of the UK, and the predicted deficits for the southeast? Would either of you like to comment on that one?
Thanks. Thanks, Ian. I'll respond briefly and then let Danny come back. So, yeah, agriculture faces a big challenge here in that it has no ring-fenced or protected rights for its access to licensed water for agricultural irrigation. So when we experience these dry summers or low flows and the hands-off flow conditions are triggered, then the farm businesses are generally the first businesses to be stopped from irrigating. This is in contrast to public water supply, where of course sort of legislation protects water use and supply for domestic use. But it raises an important question about linking water for agriculture to food security, because we need to make that link much more explicit and clear to the government, to others in the supply chain, that there is this direct link between the allocation and use of water for growing high value crops of fresh fruit and vegetables and the need to support that for food security. And I think that's where there is a disconnect. We talk about food security, but we're thinking about, can we get strawberries on Waitrose shelves on Christmas Eve? We're talking about, can we get a reliable, affordable supply of fresh fruit and vegetables for our population, given the geopolitical uncertainties and the fragility of our global food system. Over half our food is imported, many from countries that are not only drought-stricken and will become increasingly sort of problematic in terms of security of supply, but also are geopolitically in a delicate situation. So we do need to make that link between water rights for agriculture and link it much more directly to food security for our nation.
Thanks. Thoughts, Danny?
Yeah, I mean, as was mentioned there, there's the legislative protection for public water supply, but I think there's a real importance here around what I alluded to in my presentation around sort of the southeast of England being water stressed. I mean, our water resources management plan, which looks at water resources over the next 25 years, without action, we're looking at sort of 449 million litres per water per day deficit. So I think, it raises the importance of regional management planning to sort of to address that. And we are taking actions over the next 5 years around bringing in water via strategic resource options to replace groundwater that we're no longer abstracting, and then also there's the importance of water usage as well. We have some of the highest per capita consumption in our supply area of the general population, so there's important actions there around sort of smart metering, where we're looking to influence sort of 350,000 of those over the next 5 years, to drive down that sort of the pressure in this area, as well as carrying on to be as ambitious as possible with our leakage reductions as well, which we're one of the leading in the industry for. So I think the importance there is that regional management planning element of it there.
Thanks. Yeah. An issue that's particularly caught my eye over the last few years has been the whole issue around re-wetting of peatland and the potential conflict there with the fact that some of the most productive agricultural farmland in the UK is peatland, across the fens of East Anglia in particular. I'm aware that there are various projects looking at re-wetting of peatland, and under the title of paludiculture, the potential for still producing something beneficial from the land once it's re-wetted. Would either Mark or Finlo have any particular thoughts and comments on that one? Either of you fancy having a go?
I can see Mark's about to.
Yeah, it's not really my area, other than it sort of touches hydrology and ecosystem services. Yeah. But yeah, I mean, of course, the reason that fenlands are very productive is because of the buildup of organic matter. And going back to the earlier presentations, the reasons that most agricultural land isn't productive is because that organic matter has been oxidized by tillage and farm operations for hundreds of years, and so in a sense, my view is that the greater potential is not to try and squeeze a little bit more production alongside nature in those sorts of complex ways, but rather to focus on the land that's already under agriculture and to really get the incentives right to regenerate that soil, because you know, that is a huge area. Whether we're talking about global or whether we're talking about the UK, agricultural land is a very large area. And if you can just tweak an incentive to tweak, you know, the amount of carbon that's retained in that soil, the hydrological improvement of the hydrological function of that soil, then because it's such a large area, you have massive impacts immediately. Whereas if you focus on very small areas, like, you know, peatlands that may be being re-wetted, and trying to, you know, get other productivity out of them as well, then that may have a local impact, but it's not going to really do much at the sort of UK type scale.
I would agree with a lot of what Mark said there. I mean, the first thing to say is there's a lot of peatland elsewhere, so we, you know, let's you know, really focus a lot of attention, you know, in those other places in particular. But in terms of areas, you know, which are highly productive, which are highly farmed, there has been for some time this sort of idea that you do nature there and you do farming here, and I think that has to change. We need to sort of do a much better combined approach where areas are being re-wetted. Animals can be used as part of that management process, and you know, that's important, and monetizing those animals is going to be important. But yeah, I used to live in the fens and on the edge of the fens, and when there was a decent breeze, the air would turn brown because every bit of nutrient was being blown off. So it was either going into the watercourses in a way, or it was just being blown away in the wind, because so much of that land is bare. And I'm sure that has changed significantly in the last decade. I've not been back there in that time. And that there is more cover cropping, but it is about those things that I was talking about, where you're trying to get those nutrients back into the soil, manage that land better, make sure that the soil is not left uncovered over winters and that sort of thing, so that we are regenerating the virtue, regenerating the value of those lands currently under agriculture, at the same time as getting that re-wetting right.
Thanks, Finlay. Going to the questions now. Interesting one here from Ollie Crossland. I think we've fairly well established that agriculture has had huge impacts on the water environment across the world, and especially so in the UK. Holly asks, what role do companies such as water companies have in stimulating nature markets to increase the buying of ecosystem services by other companies? What networks are in place to engage other corporates who may be interested? I suspect Finlay's got a view on that as well, but also perhaps after that, Danny.
I mean, there's a degree to which I tried to answer that question while I was talking during the presentation, that you know, it's about the blended finance models that Danny talked about in his presentation. It's about making sure that there are multiple stakeholders, that there are landscape scale approaches. There is no doubt that companies, you know, like water companies, rail companies, a whole range of others, you know, they are benefiting when farmers are managing land well and retaining water, making sure that nutrients stay on the land, etc. And so if we are going to finance the changes that we need to see, it is going to be about a combination, rather than farmers simply, you know, getting the subsidy from the government that they used to in the past and being squeezed by Tesco, you know, as they have been, and food being the only product. It's food and nature, making sure that you're getting the agroforestry in there, and that's becoming an income stream, that you're being paid to hold those nutrients into your land, that there is, you know, there's a social recognition that it's not just farmers that have been farming in a particular way, it's society as a whole that is demanding of farmers that they farm in that way. Therefore, as a whole society, we need to fund and support and recognise that change.
Thanks, Finlay. Interesting to observe that the least profitable part of the whole modern food chain is the one that's actually in direct contact with nature. Something's wrong there somewhere. Any thoughts, Danny?
Yeah, I think it's some really good points there. I think also, you know, there's a number of you know, procurers of ecosystem services with different regulatory drivers, but we're all working towards similar things. And there's a danger if we all do our own thing, that farmers get inundated with schemes, it becomes complex, we miss out. And And for us, it's really about making the best possible use of customer money as well. So, I mean, I mentioned the Landscape Enterprise Network for the East of England in my talk. You know, that's a good example of a marketplace for buyers of ecosystem services, mainly within the agricultural supply chain. So you've got, you know, Nestle Purina, cereal partners, but then you've got ourselves, you've got councils as well. And I think, you know, that's a real ability to sort of for us to all pool our funds, and then also to have access to the sort of monitoring, reporting and verification of those benefits, and sharing those out as well. So yeah, that's a good model there. But I do think, you know, to get best value for money, we need to be blending finance.
Could I just add something as well, which is just farmers will do what they're paid to do, or what they're paid for. And if they're paid to do something, you know, if you know, by some miracle there was a consensus about what needed to happen to restore nature, and there was funding in place, a combination of private and public funding, and farmers were being paid to do it, they wouldn't have to agree. They wouldn't have to say, you know, I'm completely bought into regen. They get on with it because there's a value to it.
Yeah, I mean, I've had this conversation with a few people now. Around how do you encourage farmers to follow down this particular route, and offered the opinion from my 40 odd years in farming that that possibly as many as 50% of UK farmers are open to farming more in sympathy with nature anyway, but the other 50% are extremely hard-headed businessmen, and the only way you'll get them on board is when they see that there's money in it for them that they're missing out on, when the others who are doing it because it's the right thing to do are actually more profitable as a result. And at that point, you'd get an agricultural pylon. I think people would be falling over each other to do it. It's just how you capture that value, isn't it?
And just as a minor policy point, because people listening probably haven't thought about this, you know, we're talking about farmers manage 70% of these islands, and yet they are being paid per person, per citizen here, less than it costs to join the National Trust each year by each citizen. So we're talking about, you know, 3 billion quid or something like that going in across the UK, a little bit more than that now. It costs 11 billion. This was nearly a decade ago now. The figures have gone up, but 11 billion just to administer central government. So not even local government, just to administer central government is 11 billion quid, and we're paying farmers 3. I mean, it's nuts.
Yeah, you get what you pay for, don't you?
Yeah.
And we're clearly not paying for it. There's a number of questions along a similar sort of theme posed towards Danny around pesticide concentrations and nutrients that are sort of also pulled together nicely with one from Greg Davis. Question for Danny: with water flow within some groundwater aquifers being highly motile through certain geologies, how do English water companies ensure that agri-activities occurring outside their supply area don't impact upon the water quality and quantity within their supply area? If you've got any particular thoughts on that, Danny?
Yeah, no, that's a really good question. And you know, you're right. The movement of water through the chalk, through the pores matrix is complex, and we've you know, we work to the source protection zones for each of our groundwater sources, but actually you know, we've been doing a lot of work with the Environment Agency around the sort of remodeling of some of those areas to take into account areas which are actually having an impact on abstractions, and we linked up with the University of Leeds as well over a number of years to support a PhD student who deployed tracer testing as well, where you inject bacteriophage or a dye tracer test into an injection point into a swallow hole down into the groundwater, and then you know, and for instance, one of our groundwater sources in a karstic area, we injected into a network of swallow holes 4 kilometers to the southwest and detected that bacteriophage in less than 24 hours at our source. So you know, that's we then use that data to channel our engagement with farmers as well. So around that swallow hole network, the next season, you know, it was in a full year cover crop actually in some of those fields, and cover crops and spring crops in the others, to really, you know, target those measures. So yeah, it is vital that we understand, especially in these complex and karstic nature of the catchment, you know, the impacts that it's potentially having, and channel our catchment management in the right way.
Ian, do you mind if I come in briefly on that?
Yeah, sure.
So a lot of that, I think an awful lot of this, farmers and farmers organisations are becoming an awful lot better at talking to each other in this area. A lot of the conversations were about how can we stop government regulating us in this way, in the past. An awful lot of peer-to-peer knowledge exchanges taking place. And I recorded a podcast this morning that's going out Tuesday week with the head of agriculture at Natural England and Martin Lyons from Nature Friendly Farming Network, talking about Natural England's new strategy, where they've recognised that they've been very much about conservation in the past, and now they need to be about collaboration and integration, trying to sort these things. And there was anecdotally down near the A303 near Stonehenge, there was an organic farmer, been organic for years, lost his certification because of a farmer across the hedge, basically, and it was to do with water underneath the land, because those nutrients that were being put onto the land, petrochemical nutrients, were leaching through and then coming up through the soil on the organic farmer's land, which was, it's crying shame. And the only way to deal with that is to take a Starbucks strategy. So Starbucks are known for what they do. If they go into a country and they plonk down various different cafes in coffee shops in different locations, having got their anchor into a particular location, they then cluster around those coffee shops so that they just monopolize the coffee supply in those areas. And really, I think that's what we need to be looking at in terms of, the approach that Danny was just talking about there. It's about saying, well, let's get some expertise and some brilliance and some knowledge and delivery on this farm, and then work with those farmers very actively in that area to make sure that that whole watershed, that sort of watercourse area or whatever else, that cluster is functioning and working together to deliver the outcomes, not just individual farmers dotted around the country.
Thanks, Finlay.
So just to add to that, it as well, from a surface water perspective, when you talk about working across the Thames Basin, we do link up with Thames Water and South East Water for a Thames Catchment Management Steering Group, where we divvy up all the sub-catchments and link up to trial new things and implement catchment measures, so that farmers have those relatively standard funding measures that they can access across that wider area, so that when you're getting that impact from different sub-catchments, we can sort of target those hotspots and really look to make change that way as well. So it's complex in the chalk, and we also have a strategy for the surface water as well.
Interesting question here from Jonathan Fisher. Repriorities. What are your views on whatever DEFRA is going to do regarding the land use allocation for water? How to ensure greater priority for food production and security, and I would argue nature, and water management, instead of house building and net zero, which seems to dominate their earlier flawed consultation last year. I presume you're meaning in relation to the land use strategy. Jonathan, any thoughts, anybody? The first disconnect I can see is the prioritisation of a lot of development around the Oxcam Arc when it's in one of the most water-stressed parts of the UK, and whether that's actually deliverable.
I would raise maybe two points there. One is, as a geographer, I'll raise geography, and every place is different. Not just because it's different, because the surroundings of that place are different. And so any land use framework has to be extremely detailed in what it takes into account locally, and setting sort of national targets, it becomes very difficult for that reason, because every place is unique, both socially and environmentally. And secondly, because of the whole issue of economic value. We've been talking about the economic valuation, for example, of ecosystem services for 30 years, but it's still voluntary whether you take on board that kind of value. And if you value things properly and correctly in their real value to your economy, then you will end up with the distribution of those things that you need. Right, but if values are not correct, then you will have, you will in most countries of the world degrade your nature over and over and over, because though it is fundamentally valuable to you, it's not within your economic calculations. So I think geography and value are really important in those kinds of frameworks, and of course they can be highly political But economics and geography are probably the most important elements of them.
Thanks. Any other thoughts from anybody?
I mean, God, it's a tough balance, isn't it? I mean, it's a huge challenge, because all of those things are important. I mean, we have to get to net zero, but we have to be honest about the way that happens. And I think very often the science isn't up to date, and certainly in terms of livestock. And you mentioned my TEDx, We Can't Solve the Climate Crisis Without Cows, which goes into a great deal of detail about regenerative agriculture and about the methane issue and how that's been misunderstood. These things have to be updated so that there is a genuine understanding of the role of farming within the natural environment, so that we can get those regenerative outcomes. At the same time, we need building where it's needed. People need homes, and there's no doubt about that. And I think that the biodiversity net gain element associated with that, where a new development should have 10% a 10% improvement in the biodiversity, even though that's then going to be delivered off-site normally, that is an opportunity for farmers to get paid there, for nature to be improved, depending again on what those constraints are within biodiversity. So it's not necessarily about one or the other. It's about sort of how you combine these different things and balance them. And of course, food security is a national issue. It's not a local issue. And so, if that strawberry farm or whatever else, disappears locally, there will still be strawberries in summer nationally. Now, that's going to be an impact on those people locally, but providing, those farmers are able to work with technology and the internet to find ways of selling direct if they want to, or just to feed international supply chains. The question is national resilience, sort of moving away from international dependence to national resilience. And of course, food production, ferociously important, ecological security, ferociously important, but these other things are too.
Thanks. Any final thoughts, Jerry?
Thanks, Ian. Yeah, just a couple of thoughts, really. I suppose one is emphasising this regional versus national priority, and here the regional water resource groups have an important role to play. They're that link between the government's agenda for land, water, environmental management, and how those are then implemented and traded off at the regional and local scales. But of course, the role of the regional water resource groups is under scrutiny through the Cunliffe report. And I suppose many of us are waiting to see how the recommendations in the Cunliffe report will play out, and how they will change some of the responsibilities for the regulatory agencies and those that have a stake and an interest in water, environmental and land management. So I think we're in a bit of a state of flux. But of course, things like net zero, peatland restoration, regen ag, food security, net zero, they all sort of compound the complexity that DEFRA has to deal with. But I think, notwithstanding that they have to deal with these challenging issues, they've not always been particularly incisive and clear about what the direction of travel is in terms of agricultural land management policy and that link with food security. I think it's starting to come to sort of bear as we realise that our food system is extremely vulnerable to the international externalities and political and geopolitical sort of risks. But it's moving slowly, and the problem is that farming businesses need clarity, and they need sort of understanding of what they're trying to do and achieve within all those environmental, land and water agenda. So I think that's where many farming businesses are struggling. They're sort of stuck waiting for government and its agencies to make decisions so that the farming businesses can make decisions and they can innovate. They're very good at solutions, but they won't make investments if the regulatory or policy environment is fuzzy and unclear. So I think that's the challenge that we currently face.
Okay, thank you. Thanks to all four of you, to Jerry, to Danny, to Mark and to Finlo. And I'll hand back to Ethne to round out, please.
Amazing. Thank you so much. And just to echo you, a massive thank you to our speakers today, Jerry, Danny, Mark, and Finlo, to you, of course, Ian, for your great chairing, and to all of our attendees for coming along and taking part and asking loads of questions. I'm really sorry if we didn't get to yours, but I think we've had a really good discussion about the topic here. Just to flag that the next FWR event is taking place on the 4th of February, and this is going to be focused on microplastic pollution in the water environment. And you can register for this on the FWR or IES websites. If you are an IES member, don't forget to record your attendance at this webinar using our CPD tool, which you can do by logging into the members area. And if you're not a member, please do consider joining the IES to support your professional development and our work as well. I'm afraid this is all we have time for. Again, thank you so much for coming. I hope you have a great rest of your day. Thank you.